Welcome to WD Teaching. If you haven't subscribed this channel yet, click the subscribe button to get my latest videos. Today, lesson is about hydrocarbons and their derivatives. I hope to summarize the whole lesson from this video. First, let's learn about hydrocarbons. What does mean by hydrocarbons? The organic compounds which contain carbon and hydrogen only are known as hydrocarbons. How to classify hydrocarbons? Hydrocarbons can be classified as alkanes, alkenes, and alkynes. Alkanes mean hydrocarbons which have only single bonds between carbon atoms, when it's shown as a structure like this. Alkene. Hydrocarbons with one or more double bonds between carbon-carbon atoms. Alkyne. Hydrocarbons with one or more triple bonds between carbon-carbon atoms. Hydrocarbons have a special nomenclature. Hydrocarbon gets its name by using the types of the hydrocarbon and the number of the carbons it contains. Name of the hydrocarbon starts from the number of carbons that it contains. That means a hydrocarbon with contain only one carbon atom, the name starts with meth. With two carbons, it starts with eth. 3 carbons, prop. 4, but. 5, pent. With 6 carbons, hex. 7, het. 8, oct. 9, non. 10, dec. The name of the hydrocarbons end with the addition of the term by category. There are 3 types of hydrocarbons: alkane, alkene, alkyne. Alkane ends with adding ane. Alkene ends with ene. Alkyne ends with ine. For an example, alkane with only one carbon starts with meth, ends with ane. So, the name can be written as methane. With 2 carbons, ethane. 3 carbons, prop, ane, propane. 4 carbons, butane. 5 carbons, pentane. 6 carbons, hex, ane, hexane. Like that. Alkenes also named as ethene, propene, butene, pentene, hexane, and also like other 2 alkyne sounds like ethyne, propyne, butyne, pentyne, and hexyne. Okay, let's learn about alkane. Alkanes can be represented by a common formula: CnH2n plus 2. According to this formula, the molecular formula of the simplest alkane is CH4, 1 carbon with 4 hydrogen. The structural formula is like this. The name of this alkane, methane. Methane commonly known as biogas. Alkane with 2 carbons, the molecular formula is C2H6. Its structure like this. Name, ethene. Alkane with 3 carbons, C3H8. structural formula in here. The name propane. Now let's learn about alkene. The simplest alkane structural formula is like this. Its molecular formula is C2H4. Its name is ethene. Okay, now we are going to learn about derivatives of ethene. The compound derived by displacement of a hydrogen atom in ethene by another atom forms derivatives of ethene. For example, hydrogen atom in this ethene displaced by chlorine atom and form chloroethene. The compound, likewise, the compound derived by the displacement of the 4 hydrogen atoms in ethene by 4 fluorine atoms form tetrafluoroethene. Therefore, chloroethene and tetrafluoroethene are examples for derivatives of ethene. Polymers. Large molecules formed by the joining of the large number of small molecules with one another are known as polymers. The process of forming polymers is called polymerization. Let's see how do the polymers form by hydrocarbons. This is an ethene. It has double bond. It breaks one bond and forms structure like this. Thousands of these structures added together and form polymer shown as here. Small molecules contributing to form polymers are called monomers. The basic structural unit contained in a polymer are known as repeating unit. By linking the large number of small molecules together, it makes large molecules and they named as polymers. This monomer is called as ethene. It polymerized and formed polyethylene. Also it called as polythene. Likewise, chloroethene is a monomer. It forms repeating unit like this by breaking one bond from double bond. And large number of repeating units linking together to form polymer named polychloroethene or polyvinyl chloride (PVC). Another example, the monomer is tetrafluoroethene. It polymerized by forming repeating unit like this and formed polymer named as polytetrafluoroethene. It also named as Teflon. Natural rubber. Rubber is a natural polymer. The monomer of rubber is contain 2 double bonds. This structure is known as isoprene. When polymerizing isoprene, it breaks both double bonds and form repeating unit like this. And by joining these kind of repeating units, it forms polymer known as polyisoprene. Therefore, natural rubber also known as polyisoprene. Classification of polymers. Polymers can be classified based on origin and based on structure. Based on origin, polymers can be classified into two types: natural polymers and artificial polymers. Example for natural polymers: rubber, protein, starch, cellulose, DNA and RNA. Artificial polymers: polythene, Teflon, polyester, nylon and bakelite. And now let's see how to classify polymers based on structure. There are three types: linear polymer, polymers with side chains, polymers with crosslinks. Polymer molecules joining together as a line called as linear polymer. Joining polymer molecules laterally to the principal chain are known as polymers with side chain. The polymers which the linear chains are cross-linked are known as cross-linked polymers. Natural rubber belongs to linear polymer, but during vulcanization, natural rubber react with sulfur and form crosslinks. So, vulcanized rubber is an example for polymers with crosslinks. Today, we learned about hydrocarbons and their derivatives. I hope you learned well. To get my new videos, subscribe this channel and share this video with others. Goodbye.